is Mahesh and I am discussing ATM, asynchronous transfer mode for your curriculum. So what is ATM? So everybody knows this is one fantastic data link layer protocol. Now what is data link layer? So as we know, we have different layers in OSI layer. So we are talking about this layer 2 data link layer. So whatever data we are sending from upper layer, so we have to encapsulate data, we have to add CRC, we have to add a header byte in its address field, and then we have to encode the data at the physical layer, and then we have to send the data to transmission line. ATM, asynchronous transfer mode, is very popular because it is less complicated than other technologies. Like we have HDLC, one encapsulation method at data link layer, where we are adding some CRC and some header byte, and it is a little bit complicated here. In HDLC, as I discussed, the size of a frame can vary from 56 byte to 1500 byte. But in case of ATM, here we have kept cell size as a fix, like 53 bytes only. So 53 bytes, why 53 bytes only? I will come on that later. But hold these 53 bytes again further divided into 5 bytes for header and 5 bytes and 48 bytes for payload. So let us start digging. So now we can start discussing about this particular ATM layer. So exactly, ATM layer is responsible for encapsulating whole data and forming one header. So I want to draw this diagram over here. So for that I have to erase the whole diagram over here, and exactly I want to show you how a ATM layer look like, or what are different field in a header part of ATM layer. So just I can draw this one cell, like currently I am sending, I can draw this vertical diagram of a cell. So suppose these 5 bytes are there for suppose for header part. Okay, so first byte, the first byte is divided into two part, 4 bit for something they have called as a GFC, generic flow control. So generic flow control is not defined by ATM forum. Just any exactly we have kept a reserve for future use, and actually it is not defined for user to network interface. Now what is this user to network interface? So suppose cloud is there, this is suppose ATM network, and too many devices are there and they are connected with ATM backbone, suppose. So if a user is here and user is connected with this link, then this link is called as a user to network interface, UNI. And these two devices over there, they are connected with a network to network interface, NNI. So generic flow control is not used in UNI. So here we are not, if your link is connected between ATM switch and user, then we are not using this generic flow control field. Okay, but if this NNI is there, then we can use this generic flow control as a VPI only, virtual path identifier. So this may provide little bit higher number of path for service provider, because this is also field there which we have kept reserved for virtual path identifier, VPI bit. So this is about first byte of a ATM cell. Then we have this second word, that is second byte. Here we have this field also 4 byte, VPI, virtual path identifier, VPI. In this way we have 4 plus 4, 8 total bytes bits uh, VPI. But if network to network interface 4 8 plus 4, that is 12 bit we can use in a network to network interface. But in case of user to network interface, we can use only 8 bit. Then other bits are there, and they are as a work as a VCI, virtual circuit identifier. Then we have again whole this VCI bit over here, VCI, same way VCI. So we have 16 bits assigned for a VCI. So VCI, virtual circuit identifier. So total VCI bits are 16. Okay. Then what about these other field over here? These are different, like just remember that we have exactly consumed 4 bit from a byte. Okay, so remaining 4 are again divided into payload type PT. I can draw like this, PT, and this is a this I can draw over here like CLP, cell loss priority, CLP bit. Now what is exactly PT means, payload type, and what is CLP? Just I can explain this in a few moments. But exactly this is the structure of a ATM cell header, and uh, this is HEC. Then can I ask some question? What is HEC? HEC is nothing but header error check. It works as a CRC for whole this header part over here, and HEC is generated by transmission convergence, which is a second sublayer of a physical layer, which we have discussed just before. Okay, so what is payload type, PT? Okay, so we have used 3 bits over here. So first bit, second bit, and third bit, and fourth bit is cell loss priority. So PT, only one bit has been defined by ATM forum, and we are using for conjunction notification. So thank you for friends. I hope you have enjoyed this video. Thank you, Teleman.